Welcome to the 2020 Maths question 1J. The question asks us to consider a square with side length 2 and centre at the origin, and a circle with radius r and also with centre at the origin. We're told that A of r is the area of the region inside the circle but outside the square, and that B of r is the area of the region inside the square but outside the circle. With this information, we're asked which of the following is a sketch of A of r plus B of r. And we have 5 different options here. Pause the video and have a go at doing this for yourself. Let's start by trying to eliminate some of these graphs. Indeed, we can see that graphs B and E have a point where A of r plus B of r is equal to 0, and A, C and D don't have that point. So let's think about the significance of a point where A of r plus B of r equals 0. Well, A of r and B of r are both areas, so that means they're both greater than or equal to 0. So if their sum is equal to 0, then this tells us they must both be equal to 0. But that means that the area inside the circle outside the square is 0, and the area inside the square but outside the circle is 0. So that means there's absolutely no area between these two shapes, which means that they are the same shape. But this is simply not possible because one's a circle and one's a square. So we can see that the situation A of r plus B of r equals 0 can never happen, and therefore we can cross off B and E as possible sketches of A of r plus B of r. So now let's move on to a new page and try to establish which one of A, C and D is the correct answer. Okay, so here are our 3 remaining possibilities, and now what can we try to do in order to determine which of these is a possible sketch of A of r plus B of r? Well, we could try and find the formula of A of r plus B of r, but that's going to be really tricky, specifically around the point when the circle and square are intersecting. So let's instead think about the 2 extremes. So firstly, when r is very small, when the radius of the circle is very small, that means that it will fit inside the square, and therefore the area that's inside the circle but outside the square is 0, because it's non-existent, and the area that's inside the square but outside the circle will be all of the area inside the square minus the area that's inside the circle. So the area of the square is just 2 squared 4, and the area of the circle is pi r squared, so therefore B of r will equal 4 minus pi r squared, and therefore their sum is 4 minus pi r squared. So this will be what our curve needs to look like for small r. And what shape does 4 minus pi r squared have? Well, it's quadratic, so it's a parabola, but it's going to be a downturned parabola. And we can see that A and D both have a downturned parabola for small r, but C doesn't. C is turning upwards, and therefore we can eliminate C. That's not a possibility. So now let's similarly think about the case when we got r very large. Well, then the circle will be very big, r is the radius of the circle, so the square will fit inside the circle. And in that case, A of r, which is the area inside the circle outside the square, will be all of the area inside the circle minus the area that's inside the square, so it will be pi r squared minus 4. And B of r is the area inside the square but outside the circle. That will just be equal to 0 because this region will be non-existent. So therefore, in that case, A of r plus B of r is equal to pi r squared minus 4. Which is another quadratic expression, but this time it will give us a upturned parabola, and this is the behaviour which we expect to see for large values of r. So if we look at D, we can see this is a parabola which is turning up. However, A we can see is downturned and it's curving around like this. So therefore A is not a possible sketch of A of r plus B of r. And so by process of elimination, we are just left with option D. So we can see that D must be the sketch of A of r plus B of r. So our conclusion is that the answer is therefore D. So we are done with the question.